Wodonga, that's the one. So, a little bit about me. I am a GStreamer maintainer. I've been a GStreamer contributor since 2003. I do embedded firmware development and am primarily responsible for GStreamer's DVD playback infrastructure, as well as the Arena media system. I also hack on RepSnapper, which is a piece of RepRap 3D printing host software. And in the past I've worked for Fluendo, for Oracle, for some others, but most recently I've co-founded Centricular with Tim Philip-Muller and Sebastian Droger as a new company for doing GStreamer and Linux multimedia consultancy. Where we live, we call it Widget Grove, my wife and I. We moved there in 2010 and as a bit of an inspiration to get out of the city and have a bit more land and do a few more interesting things. So we found this parcel. It's a bit under 2 acres with a house up in the corner and then basically a big empty sheep paddock attached to it. It's quite a nice place to live. The house that George built, as we call it, was built by a retiree who was a concreter by trade. Of course, we don't really own it. It belongs to these guys. This is Fry and Bender. So we have some sheep run around in the backyard, and we occasionally put them in the freezer. We've got a nice veggie patch that grows us pumpkins and potatoes and peas and whatnot. We have 1,000,001 fruit trees. You name the fruit tree, we probably have it. We've got 70 fruit and nut trees in total, and they're a bit hard to control sometimes, but you know, I got a chainsaw that's keeping them in check. So yeah, we get bundles of nice fruit off it. Here's the map. These are all our trees. We went around and labelled them all when we moved in. It's kind of funny. George really concentrated stuff. He put them all together and then left this giant empty space, which works perfectly for us because we're turning all of that into gardens over the next few years. The one major problem we've got, of course, is we live in Eastern Australia where this little guy is rampant. This is the Queensland fruit fly. It used to live in Queensland, but as the weather has gotten warmer, it's gradually marching south, and these guys get into the fruit, sting it, lay their eggs, and then your fruit turns into a rotting brown mess of maggots that you can't do anything about. And unfortunately, the only way to avoid it is to put big nets over them as soon as the bees have been through and fertilised things. It's a big pain when you've got 70-odd trees to do. So far I managed to do about 10, and then we go around to the other trees and throw away the fruit before they can become a breeding ground. So we've got these guys. These are cute. These are some ducklings we had born about December. There's their mum at the bottom. She can't really see. She's actually a chicken. She got confused and sat on the wrong eggs, and she was very distressed when these guys decided to jump in the pond. Eventually she just decided they were defective chickens and abandoned them, but they were big enough to cope by then. 2 weeks ago we had these guys move in. It's a swarm of bees. Flew in from my next door neighbour. He keeps bees. He has 20-odd hives and produces honey. So he came over and showed me how to deal with them. So now we are growing our own honey as well. It's kind of nice. Last year we had this little guy. This is Arthur. He arrived 2 months early and was very, very small. Spent these first 5 weeks in the hospital before we got to take him home, and then we had him home for a week and he stopped breathing on us, and I had to resuscitate him on our dining room table, and that was a bit distressing, but he made it through. He's good now. Nearly 10, nearly 11 months old. You can see he's got a tooth in there. Yep, so I mentioned we've got sheep. They recently had lambs, so we've got 3 lambs running around now. So we have the one ewe, that's Zoe on the left. She had triplets, which is pretty unusual. Even more unusual would be for a sheep to have triplets and then keep all 3 of them. So that didn't happen. She rejected one guy, she boots him away if he comes too close and won't give him milk. So he's being bottle fed, and will one day, maybe in a year's time, be delicious. It's a baby chicken. Yeah. Oh yeah, these guys, these are Rosemary, Garlic, Lamington, Zoe, George, he's named for the guy that built our place. You can just see Carl's butt on the right there. And Lenny, his other brother. These are those baby ducklings, all grown up. Here's some baby chickens. Chickens, I don't know if anyone's got familiarity with chickens. They like to destroy your garden. They do this thing called dust bathing. They go and cover themselves in dust to kill off their fleas and mites and stuff. Makes a mess of the gardens, but you know, it's worth it. It's a day and a half's haul of eggs there. We give away a lot of eggs. We started filling in the paddock. I had this plan because we've got a 4-bedroom house. My wife has an office, I have an office. We now have a baby room. We're out of bedrooms. So I decided I would move my office out. Planned myself a man cave, so this is my new shed, divided into 2. This bit's my office and this bit's my workshop where my routers and mills and circular saws will go. So we had some guys come in and build that. Okay, all done. We have our chickens. I decided to build myself a solar panel. So I ordered a bunch of solar cells from China and wired those up, stuck them on the roof of the hay shed. Got a battery, charger, multimeter for measuring how much power is coming in. So now I have half a project finished. At the moment, it keeps the battery charged. The end plan is that will power some computing. It'll what I really want is to be able to go away for a weekend and not have to worry about the chickens. So that's going to be running an automatic food dispenser and a little door to open and close the chook yard at night so that they can be locked away automatically and things can be safe. So thank you very much. Any questions? Oh, wait a second. Yeah, sorry, forgot which conference I was at. It's not the sheep and chickens. Okay, so my plan. We have all these things going on, and I am a fair way away from the house if I'm out in my new man cave. So I had this plan. Let's install some cameras, and I can keep track of things that are going on, because we've had instances where I wake up in the morning and I go out and the sheep have a patch torn off them from a dog that's jumped over the fence or a fox or something. We've lost some ducks and chickens to foxes when we were away too late, and a baby that at the start made me extremely paranoid after he stopped breathing left me. So I came up with this plan, installed some cameras and built some prototypes. Here's my first prototype of a night vision camera, carrying it around and just doing some test filming to see how well it could see. Works pretty well. I was not too dissatisfied, so I deployed that. It's Baby Cam Mark 1. Captured some good footage of Arthur not doing anything distressing, but that's good. So when Lamington arrived, he because he was rejected by his mum, he wasn't getting the milk or the warmth that the other lambs were, so he got a bit hypothermic. I had to bring him in the house and put him in front of the heater for a while, so he got a baby cam for a little bit as well, so I could monitor him. I've got one going out the window of my shed now, so I can keep track of my sheep. The colours are like that because this is a homemade infrared camera. So I'll show you. This is what I've got. I've got one of these guys, big infrared illumination torch. Got a Logitech web camera. I have the ability to pull things apart. So yeah, you go inside the webcam, you take the lens off, you can see inside there's a little pink bit of glass that filters out the infrared, and you get your soldering iron and you heat that up enough to melt the glue, and then you yank it off, and what you get is something that no longer displays colours right, but which can see at night, so that's cool. And then I also have this guy. This is a Raspberry Pi with the Raspberry Pi camera module attached. So that's sitting in the corner of my new shed, giving me this view. But we'll get to that. So the software that is running this is really trivial. It's take GST RTSP server module, go into the tests directory where there's go into the examples directory where there's a whole bunch of simple samples. You go into the test video sample and you replace its pipeline with something that does what you want it to do. And at the end of it, you make sure you put a payloader or several payloaders, and you call them pay 0, pay 1. And after that, the RTSP server will discover those, and away you go. I have a few of those scattered around, one for each camera. And then in front of that, I have an RTSP reflector that's really just another instance of the RTSP server that fetches from those other ones, runs it through a depayload and repayload just so that I can get the name pay 0. I could use an identity or something, and that would probably work as well. But anyway, this was the 2-second hack that did it. And away you go. You can suddenly watch your cameras from wherever you want. Oh, you punch a hole in your firewall as well. And this other piece that I wrote, the GST Raspberry Pi camera source that wraps around the Raspberry Pi camera, which I should explain a little bit. That was inspired by, one, my need for capturing from Raspberry Pi camera, and two, that the solution to that on the internet seems to be run the Raspberry Vid binary, which spits out H.264 on the standard output, and you pipe that into GStreamer, and that made me feel a bit queasy. So I thought, well, let's take that same code, wrap a GStreamer element around it, and then at least we're capturing natively packetized data. We can timestamp it, we can do negotiation, and we can set the parameters with the GStreamer controller and all those sorts of nice things. So that took a day or so. Simultaneously, and later, I found out that there is a separate project to convert that, to write an OMX general camera source that ends up giving you the same functionality, but just inserts itself in a different layer of the API stack that Broadcom offer on the Raspberry Pi. So it's targeting the OMX APIs instead of the MAML APIs that sit on top. And also that Collabora for a while have been working on putting the correct solution, which is to wrap the Raspberry Pi's camera in a Video for Linux element driver that GStreamer's native Video for Linux source can then capture from. And that's the long-term solution. But for now, my hack works. I'm quite happy with it. So I wanted to do a demo, but there's one problem, which is that it's 3 p.m. now, which means it's 1 a.m. in Australia. So I thought, that's going to be a little bit dark. Came up with this other idea. I went down to Aldi, and they were selling these things a little while ago. They're a PowerPoint switch that has a little remote control, and you plug it into a power socket, and then you plug your device into that, and you can click the button on and off. So I thought, okay, that'll be cool. I can turn my lights on and show you some of my streams. So I built this thing. This is a Arduino with a 433 megahertz receiver and a 433 megahertz AM transmitter on it, and I sniffed the wireless protocol and decrypted that, and it turns out it's really relatively trivial. You can just duplicate what the controller sends and then send out the same things, turn them on or off, so that's fun. And then there's one more piece that I need to be able to trigger that remotely, so that led me to something else I've wanted to implement for a while, which I've called Fuchsia. She is my new friend on Jabber, and she can take commands from me and then execute them in the house. I've wanted one of these for a while, the friend that lives in your house, the ghost. I called her Fuchsia because she's named after Titus Groan's sister from the Gormenghast books that I always enjoyed. But then later I realised that if my house is called Fuchsia and I've got cameras there and telling me things going on at the house, then sooner or later I'm going to be able to turn to my wife and go, "Great Scott, we've got to get back to the Fuchsia!" Or, "Isn't it great living in the Fuchsia?" So, let's see. This demo will rely a little bit on, whether the conference network is any good. It's perhaps a little bit wriggly. So there we go. Hooray, my shed. Okay. Now where did I put my... Here we go. Empty. So we go. Power, workshop, lights. Says OK. Go back. 2, 3. Ta-da! Okay. And okay, so then there's this other one that's pointing out the window at night, which I bolted this onto the window on Thursday before I left, and put the spotlight on, and then thought, gee, I hope I pointed those in the right direction. Yeah, so the spotlight's illuminating this nice little circle underneath where the camera can see. But anyway, that one needs a little bit more work. But that's a view out the window of my shed. The sheep might have wandered past and given us a glare, but anyway. So yeah, all right. And then here's the other angle in my shed. This is the other machine sitting in the corner. It's got a more normal... It's not the Raspberry Pi camera. This is just a webcam attached. Sorry about the delay. This is actually it spinning up the RTSP in the thing. Oh yeah, there's this other problem, which is I haven't done anything to make sure that the stream starts with a keyframe. So you drop in and GStreamer just starts decoding with garbage. But that'll refresh in a second. There we go. Right, there's the corner of the shed. That's my lawnmower. Right. Yep, we'll turn that off. Here she does some other stuff as well. I don't know if this will... She can do... Play. Hello. Or maybe it's already in play. Hey, there we go. Can you guys hear that at all? Yep, live streaming from Australia. By the way, it's 1 o'clock in the morning and my shed lights just came on and someone started playing music. Yeah, but this is 30, 40 metres away from the house, and hopefully she's asleep unless like I was told the other day, Arthur decided to wake up at 4 o'clock in the morning because today was the day he was going to learn to crawl. Woke up with a determined gleam and crawled for 4 hours until he had it mastered and didn't let her sleep that whole time. But yeah, all right. And then she can also do this, which is to disable my cameras so that, because it's not actually secure in any way. If you knew the URL, you could go and hit those. So she can start and stop my RTSP streaming server for me. So there's a few more things I want to do with this. I really want this to be a monitoring thing where it'll tell me if a fox comes after my chickens and wake me up without me having to do it. And if someone comes into my new shed and starts stealing stuff, I'd like to, detect that and maybe capture a picture of their face. I'd like to have a proper security system out of this, so that's like be able to get a high def stream to the hard disk or a low def stream across the internet to the phone, or some combination of both. So that's doable with RTSP server. You split up, you capture it once, and then you split the data out and encode it 2 different ways, set up 2 different, you use a custom RTSP media that can generate 2 output URLs that give you different things. Then feeding that into an alert system that Fuchsia can notify me. She's on my phone too, by the way. Simple Jabber client. Works good, having her tell me notifications. And then later, XMPP video streaming over telepathy or something like that would be cool. Which brings me to part 2 of the talk. I promised to mention something about clock synchronization. So Arena. Arena is the project I talked about last year. It's a house-wide media system. That's what I actually play and pause when I send Fuchsia commands. So Arena is a distributed media player. It's a simple idea. Run a client on each machine that you want to subscribe. You run a server somewhere. They all talk to the server. The server shares a clock to all of them, shares a timeline, so that they can work out when each sample should be coming out the speakers, and some command and control to tell them all to play or pause, and some access to some media so they can all have the content they're supposed to play. The basic premise is to use something that's been in GStreamer for a long time, which is its network clock implementation. You can publish a clock on the server. In this case, I'm just publishing the system clock time. You can subscribe to that clock on each of the clients, and it will do some magic in order to make you ask the local clock what's the time, and it'll tell you what the time is, you know, sort of like an NTP, but without a separate daemon, without affecting the whole system. You're only within your GStreamer pipeline. I serve files over HTTP to each client. There's also an RTSP module, but there's not really that much difference between the two on a local network. And I send JSON snippets around for the command and control, and it works. It works well. And that's what I showed last year. Had new features since then. Collabora implemented a nice Android client prototype that just, you put it on your phone and it'll play whatever it's told to play. So they've got that demoed at the Collabora stand out there if you've wandered past. The original URI had a next button, play and pause, and you couldn't, and volume controls. And you could turn on and off a client, but you couldn't, you know, jump to a particular track. You can now jump to a particular track as long as you know what number that track has in your 5,000 song media database. But hey, turns out I don't actually want to do much more than skip a song that I don't like. So I very rarely actually use that unless I have a particular craving. Then I go and look through the playlist, find the entry I want, figure out what line number I'm on, and then type that into this box. But, and Nicolas de Fresne also gave me a patch recently to make it so that instead of just playing from the list of files on disk, you can tell them to play any URL. So, which is something I had thought about adding, that you can now sort of generally have a DLNA server over there, and you tell everyone to go and play a DLNA URL, so you can get them all to play some web stream or off a file server. So that's kind of cool. I built some hardware for this, or I'm building some hardware. Most of it's actually, you know, my laptop, the server in the corner, and the media center in the lounge room, and my phone, and they're my outputs that I have that follow me around. But also working on this one, I have this old LG stereo that the volume control broke, and the people that didn't want it, so I wired some extra bits in that let me replace the volume control signals. I've got an old Beagle board that has audio output and can plug a wireless network card into, so I can mount that and then have a stereo in the corner that is on my network and does what I tell it to do. I added some NFC stuff. I met a guy who works in my town, and they run this business called Tagster, making NFC dots you can program. And so he gave me a bunch of samples of those. I programmed a couple of them, so if I put my phone down on my desk there, the music starts playing, and if I put it over there, it pauses. It's way easier than finding a button and hitting a button. So there's a bunch of stuff I'd like to do. There's a problem. One problem is the service discovery. Is you run your clients, and how do they find their server? I implemented Avahi as the basic thing, but getting Avahi to run on the Android is a bit of a pain. Apparently you can do MDNS stuff on Android, but it needs to go through a different API. So I need to look into that, or maybe look into UPnP, or maybe just forget the whole thing and just do a simple UDP broadcast and see if I can find my servers on the port I expect them to be on. My UI, I sort of put to do, but I don't know what more my UI needs. It's perfect. Some kind of media library that isn't just a playlist would be good. Following, maybe I'll just steal rhythm boxes. This is GPL after all. And the important bit, which is the synchronization, it's generally good, but it does glitch. Sometimes you hit play and that guy over there will be audibly out of sync, and you pause and you play again and he'll be like, yeah, no, that never happened. say. So that's all about how does the clock synchronization work internally, which I might go into in a little bit more detail. So here's the basic situation we've got. We've got the Arena server at the top, we've got the client at the bottom, multiple clients. Each of those guys have a net client clock in them, and that net client clock sends a ping, sends a packet across to the server some number of times per second, receives back a reply that has the current time is blah. So the net client clock records the current time, sends a packet, gets back the reply, records the current time, looks at how long it took to, so it's got a start time, a finish time, and then somewhere in the middle it's got an observation of when the server sent its reply. From that it synthesizes a timeline, interpolates it using the actual local system clock, figures out a rate and a offset. And then you have your GStreamer pipeline, which you say, you don't let it pick a clock. You tell it, use this clock as your clock, and then what that does internally is the audio sync gets told you're using this clock. It says, hey, that's not my clock. I'll slave myself to that clock. And then internally it does its own set of n times per second, query the time of that clock, and then look at my local time and work out what my rate is relative to that. So you've got this sort of double linear regression and approximation estimation thing going on. In the case of the net client clock, it sort of does that round trip time, which might be 1 millisecond, hopefully not because it's a LAN, but it gets back a time in the middle of it, and it estimates that observation must have been made about halfway between sending and receiving, assuming that the network is. It takes the same amount of time to send as it does to send back. So we start off, we poll the server every 100 milliseconds, so we're doing 10 a second. We keep 32 samples, so 3.2 seconds worth of observations. We wait until we've got at least 4 of them, 0.4 seconds and we do a linear regression. We observe the time as the average of the send and receive divided by 2, brackets in the wrong place, ignore that. And then you adjust your polling frequency once you've done some regressions. If your linear regression is quite tight, if your R-squared is quite small, then you extend out the time between pings and assume that you're matching quite well. And you get a fairly good line. You can't see the blue line, it's under the red line. So, good. You look at the difference between the two, and there's a little bit more noise in there than is visible on the big graph, but it's really not too bad. Those times are in milliseconds. Your error went down to 0.3 of a millisecond behind the main server clock, and it got as high as 0.06 or so of a millisecond. So that's pretty tight. That's, certainly tight enough for video. It's tight enough for audio if it's stable enough and you don't muck around trying to track exactly that error curve. If you average that out a bit in your tracking, that's good, and it is doing that. So most of the time it works pretty well. There's a couple of problems with it. One, it does 4 observations at the start, waits 100 milliseconds for each one. Oh, and the one that's not in here is you have to prime the net client clock with a suggested start time. So you sort of have to know about when you expect the server time to be, and it's going to report that time for its first few. If someone queries the clock time before it started measuring, it'll just report that one. So, 0 is in inverted commas there because it's whatever you told it 0 was. There is some problems with the accuracy, I think, that sometimes it does go wrong. And stability in particular, there's a big difference between those observations I showed you that are done on a wired link versus on Wi-Fi. On Wi-Fi it's a little bit weirder. The graph went weird, I don't know why, but it's still pretty, it's still pretty stable, but there's a bit more noise. In particular, there's one there where it shoots all the way out to 60, can't even see that line, sorry, it's washed out, but it peaks at 60 milliseconds, which is enough to trigger the audio sync to make a glitch, because the audio sync by default is using a skewing algorithm, and will create an audible discontinuity at that point. So that's the net client clock. It synthesizes something, and then we slave our audio clock to it and try and play samples at the rate that matches what that is. And there's a couple of algorithms for doing that matching. The default is to skew the audio. There's a resampler, which is a really simple repeated sample, introduce distortion kind of resampler that not so great. And there's a new third way that we got a patch for, where you externally you publish the parameters to someone, because you fire a signal and let the software handle it. The software can set that mode for situations where you have a hardware PLL that you have adjustable parameters. You can control. You can tell the PLL slow down a bit, speed up a bit, and actually just keep playing samples, but let the hardware go faster or slower. That's another problem. When you change tracks, or your clock gets reslaved because you're playing a live pipeline, you pause and restart, or you go back to ready and swap files and come back up again, and you get a new master set on your audio sync. You do set master, and the audio sync goes and resets its interpolation parameters, and glitches a bit more so you always get this little glitch at the start of swapping tracks. To which I'm thinking maybe you can store slave parameters between invocations or something like that. Like you're slaved to that clock, and you're talking to Pulse Audio, and you've taken a good measurement of what the rate is. Maybe you can store that in some meta on that clock, so the next time you do a Pulse Audio sync that's talking to that same clock, it can just go, hey, do you have any stored parameters that my previous incarnation put in there? And just start off with those instead, maybe. Anyway, that should probably be in the future work slide coming up. There's a little diagram showing the difference between skewing or resampling. The top one, you just play the buffers, one sample per sample, whatever the audio clock is, and then as soon as you drift 40 milliseconds out of sync, you glitch and go back into sync. So you end up with this stutter. That is over demonstrating the effect. You might get a stutter once every 10 minutes or something. It'll go 40 milliseconds, and if you coughed, you could cover it and no one would notice. Or you resample. If you can set up a resampler to stretch the audio just enough, then no one would ever notice again. So I wanted to do, there are some improvements I want to do in the clock slaving and the audio. So I thought, okay, I'll start with collecting some measurements from my clock. I had this crazy idea I've got a net client clock over here and a server over there, and I want to assess the difference. Maybe I can set up a serial line that I know the latency, and I can send timestamps across. And then I woke up and the alcohol had worn off, and I felt better, and I had this better idea of a clock bouncer. So I wrote that. It's just a really simple thing you run on machine B, and you run both your clocks, your client and your provider, on machine A, and you tell the client clock, go and talk to machine B, but actually machine B just goes across and asks. It sends the packet straight through back to machine A, to the provider, gets the reply, sends it across again. So effectively what you have on machine A is a way of having a clock running on the other side of the network, but you actually still have access to the same clock it's supposed to be providing, because it's shipping the system clock, and you can directly compare the two samples and say, how accurate am I? So that's how I got those graphs to show how well are we actually tracking the remote clock. And I did this experiment where you then stop the bouncer in the middle and see how well does it track it. How well had it estimated the rate? Did it, was it kind of doing lots of little adjustments that are actually quite inaccurate, or was it fairly well tracking the slope? Turns out it's not well tracking the slope. You turn it off for 10 seconds or something, and you drift 60 milliseconds really quite dramatically, and then you turn the bouncer back on and it overcorrects and then gradually homes back in. So I really think it could estimate the slope better than it does. So that's one of the things in the future work. So there's So there's two parts to estimating the remote clock. One is what is the offset and what is the slope. So for slope, the further apart your samples are, if you're expecting that it's a linear time, then the further apart your samples are, the better you can estimate the slope of the line and remove your error. For offset, at the moment, if you get a delay in the network when you send your ping and pong across, you end up with this large round trip time and you estimate, oh, it must have been in the middle. But really that doesn't happen. If you get a ping that's a millisecond long and a millisecond long and a millisecond long, and then you get one that's 5 milliseconds long, you know it's not 2.5 milliseconds. Something went wrong either sending or receiving, and you've got this big uncertainty. We don't do anything with the uncertainty. Really, we could bias towards things with a lower round trip time. We know they're more accurate. We know that the observation really must have been in the middle of that. So I think that there's some kind of smarter statistics to do there, which would help everyone. It would help both the network clock and the general audio sync slaving, because they both use the same bit of code. They both produce observations of a remote clock and then follow it, do linear regression and follow it in some way. And there's some inspiration to be taken from the precision time protocol and the PTP daemons that are out there, because they have a sort of multi-step dance of synchronizing, and they're within microseconds, like we are, but potentially more stable and resistant to delays, say the kernel being busy sending a file that's multi-gigabytes and not sending your UDP packet out as quickly as you might hope. You can work around that the same way PTP does by actually asking the kernel to timestamp when did you send this packet, when did you actually receive this packet. You can get that out of the network stack and then at least remove that uncertainty of how long did it sit in my kernel's network queues waiting to go out or waiting to be given to me. And then improving the way that base sync handles these kind of slaving cases, because if you've got hardware that you can adjust the PLL and play things out faster or slower, that's great, but that's not the general case on a PC. In a PC, we would want to resample in software and feed it out at a slower or faster rate to whatever the audio device is happening to do. And so improving the resampling algorithm that's either in the audio sync or having it so that you can plug audio resample in front and it would negotiate what adjusted rate you want to play, and it would do the resampling, do a high quality resampling would be good. And as I mentioned, perhaps storing the slaving parameters in between invocations of your audio sync so that it remembers, oh yeah, I was 0.002 of 2 parts per million wrong last time I was invoked. Let's start with that as an estimate. So, thank you very much. Does anyone have any questions for reals this time? Nope. Good, clear and concise. No, there's.
Hi. What happens with your two players which play synchronized out if one pipeline decides to increase the latency?
You don't. So I play from a file on a HTTP server, right? So they both go and fetch it as fast as possible, and as long as you can stream to that many clients simultaneously, it's okay. In the RTSP disabled code that I played with briefly, and then it didn't immediately work, and I thought I'll just put that aside. You can always do a fixed delay kind of thing. It's not a live playback scenario, and for me, I can always just say, let's leave a quarter of a second or half a second, and everybody, you have that much headroom to play to. But really, you could do an RTCP style thing where you're measuring the maximum latency of any given client, and you could tell everyone to adjust to that as well, and you could again do it smoothly over time. But really, if one of the pipelines is having so much trouble receiving the stream and joining the group that they can't get within the latency bounds of that, then it's probably best just to do a glitch, pause and restart again. so that everyone can immediately be in sync.
Yes, I didn't quite get what is the reason that you need time synchronization in this camera system?
In the camera system, it's not. Sorry, this is a two-part talk. This is my camera system where I can go and I can watch my sheep frolicking and fighting with foxes. And part two, where I want to listen to synchronized media and watch movies around my house.
Got confused. Sorry.
Yeah, there was a slide briefly in there.
Hello. How did you condition your wife to let you do that old cool stuff in your house?
By marrying a geek with a computer science degree who was raised on Lego.
I'm
It's a
pretty
fierce diet, but she survived it.
I'm pretty envious that she allows you to do that.
To be fair, I resuscitated our child on our dining room table. She owes me. Plus, she makes me do the nasty stuff, like burying the sheep.
Questions?
All right. Thank you very much.